Hi guys, in today's video we're going to be looking at a fairly cool reaction that you can demonstrate to the class that involves creating several different colours of fire. It's a really cool demonstration that the kids absolutely love. It gets them really excited about science in general and about chemical reactions in particular. Now, because it does involve burning, there are some safety precautions that you should be taking. So you must be doing this on heat-proof mats with burning dishes as well, a heat-proof burning dish. You want to be having a few extra ceramic mats on standby in order to extinguish the flames just by smothering them. A good idea to have a fire blanket as well. And worst case scenario, might as well just prepare for it just in case, is to have a fire extinguisher on standby as well. So that covers all your safety bases, and as long as you're familiar with using each of these, it's a perfectly safe experiment to do. And I've never seen it go wrong. There's never been any need for any of these safety procedures to be used. Just a good idea for your risk assessment to have them on standby. But the benefits, far outweigh the risks with this one, because it's just such a cool illustration for the kids. So, in terms of learning what's actually going on here, full disclosure, I see this one as more of just an edutainment lesson. It's a cool wee demonstration without necessarily too much high value learning in it. The kids aren't really doing much, they're just sitting down and watching. But there are some interesting things that you can talk about during this. So in terms of outcomes that you can take, anything to do with chemical reactions, because we have got a chemical reaction with alcohol and oxygen going on here. So the reaction between different chemicals to produce a new product, looking for signs of a chemical reaction, all of that kind of comes into it. So what we're burning here is alcohol in the presence of oxygen, and the products of that reaction, though we can't see it, are carbon dioxide and water. I'll talk about the other learning points that are relevant to this, though they don't necessarily tick any experiences and outcomes. They are still quite interesting nonetheless. So I'll talk about them once we get this started. So all I'm going to do is I'm going to light each of these. And I'm going to try doing it one at a time, just to allow it to be a bit more steady and methodical. So I'm going to light the first two just now, and you'll see it burns with I've actually got some residual salt in that one, obviously just now. It doesn't burn with the brightest flame ever, just there. But this is just the pure alcohol. This is alcohol with a little bit of salt burning. That's most of the salt starting to burn off now. I'm going to add a bit more salt here. So the colour change that we're going to see in this one here is from sodium burning. And if I just sprinkle that on there, you'll see how drastically the colour changes and how quickly that changes there. So that's the result of sodium there, and it's quite a vibrant colour. So it makes the fire far more engaging, far brighter. Next, we'll light the next one over, and I'm going to put a little bit of copper chloride in this. So copper produces a slightly different colour of flame, which is still quite cool. Now this is actually a type of salt as well. It's not sodium chloride table salt. It's not the kind of salt that you would eat. But if I throw that in there, I actually threw it too hard and it spilled over the edge, but that's fine. You should see it changes the colour quite significantly. So that's the copper there. I'll just leave that. And that tends to hold the colour of the flame for a longer period of time. Next up, I left the lithium out of the way. I'll light the next one over, and we're going to do lithium now. And actually, I should have moved this out of the way. That is bad of me. So I'm going to light the next one over, hopefully. And now we're going to add a little bit of lithium to this. So lithium, again, is actually a salt, but it gives a slightly different colour of flame. So it should be a more sort of orangey red colour there, which is quite cool. There we go. So that's your lithium. Copper's really going for it there. So you actually get a secondary reaction with the copper that makes the fire actually burn up that little bit brighter. If at any point you start to feel uncomfortable with the size of flame coming off here, you can just smother it quite simply with that. But I'm perfectly happy with that just now, and it's a pretty cool effect. Lastly then, the one that I'm always a bit more cautious with, so don't throw on as much, because it's a bit more, it's somewhat of a more sudden reaction, but visually quite engaging. This is potassium permanganate. I'm going to take just a small amount of potassium permanganate here, a very dark substance, and flare. Actually, that wasn't nearly as bad as I've seen in the past. So just a spoonful, and you get a cool sort of purple flame coming off there, which is quite nice. So I'm going to show you quickly how to extinguish these. So the first couple have already gone out. If I wanted to extinguish these other ones early, it's nice when you get them all going at the same time, but I was taking my time with it and being fairly methodical. If I want to extinguish them, I just cover it over there, and that's it. Okay. So, what other learning can take place here? Well, we've talked about chemical reactions already, but why is the colour change interesting? Well, or where's it used, more to the point? One thing that the kids will be familiar with is just fireworks. So each of the colours in a firework is produced by some other chemical burning. If you see a sort of purple colour, there's a good chance it could be some sort of potassium. If you see a very sort of orangey yellow colour, a good chance that might well be sodium. Lithium produces that sort of red colour. And there's other ones that produce other colours. You've got strontium, you've got barium, and they'll all produce slightly different colours. But that's a direct product of the chemicals that are being used. So that's an area with which the kids will at least be familiar. On top of that, though, you've also got some sort of historical relevance to this. So looking way back in time to earlier chemists, the likes of Humphrey Davy, who discovered loads of different chemical elements, some of the ways he discovered some of these was by burning. He noticed that when he burned a particular compound, it burned with a different colour, and that indicated that, hey, there must have been a different chemical present within this. So yeah, that's one of the other outcomes within it. This is also something that science uses now in order to identify chemicals within an unknown compound. So if we have an unknown chemical, we don't know what it is, we want to find out, one of the things we can do is we can burn it and use fancy technology, spectrometers and all that sort of stuff, to actually analyse the light, the electromagnetic waves given off by it, and that can tell us what chemicals are actually present within that particular compound. So it's not completely irrelevant. There is some science that you can impart to your kids through this, but above all, if we're being completely honest, it's just a nice little demo to get the kids a bit engaged. So yeah, give it a shot. It's good fun. Cheers.